Okay, everybody, let's get started here. Basically, I'll remind you, you can stop the video, try reworking the problem, then play the video and see if we agree on our common answer here. Okay? All right. A student's required to take a science, a science and English and an elective in the coming semester. He has the option to choose from 5 sciences, 4 Englishes, and 10 electives. How many ways can he select a class? All right, well, this is what he needs to do. Pick a science, pick an English, pick an elective, all right? Where are they coming from? 5 sciences, 4 Englishes, 10 electives. I start picking, since I'm only picking 1 from each group, don't care about replacement. So 5 times 4 times 10. Since I am only picking 1 from each group, we don't care about order. Remember, replacement and order are group specific. I am working with 3 separate groups here. So 5 times 4 times 10 is 200. Okay, you're going to be actually calculating the final number. I'm not going to do that here, okay? Step 2, a username is required to make up 2 different letters followed by 3 different digits. How many possible usernames are there? What do I need to do? I need to pick a letter. I need to pick a second letter. I need to pick a digit, a second digit, and a third digit, right? Where are they coming from? 26 letters, 10 digits. I start to select 26 ways for the first. It's a username, okay? Different letters here. It says different, so I can't put something back. Pick the digit. I can't put it back, so notice how my numbers are going down. So 26 times 25 times 10 times 9 times 8. I am not going to divide. Why? Because there's order. Usernames have order, so the order selection makes a difference. So there's no division here. If you multiply this together, you get your answer. Step 3, a committee is made up of 4 people that can be chosen from 20. How many committees are possible? What do I need to do? I need to pick 4 students from 20, right? So I need to pick a student, a second student, a third student, and a fourth student. Where are they coming from? 20 students, correct? I start to select. First student, I can't put them back because I need 4 people on the committee. So the number's going to go down. 20, 19, 18, 17, right? So I get 20, 19, 18, 17. Last thing I do is I ask, do I care about the order? If I'm first, I'm on the committee. If I'm second, I'm on the committee. I don't care about the order, so therefore I have to divide out by how many I picked factorial. 4, 3, 2, 1. Do your math. That's your answer. This next question. Now the committee of 4 people, okay? Now the committee of 4 people will have a president and a secretary. So I'm just emphasizing I'm not adding 2 more people to the committee. We'll just say it's coming from the 4, okay? So the committee has 4 people on it. They're going to be a president and a secretary. What do I need to do? Well, I need to pick a president. I need to pick a secretary, but then, so we'll put SEC for secretary. Then I need a student and another student. There's 4 people on the committee. First is president, second secretary, then the third and fourth are going to be just students. So, where are they coming from? The 20 students. I start picking 20, 19, 18, 17 because I can't put them back. So 20, 19, 18, 17. Now, do I have order? Well, for the first 2, I do have order because if you pick first, you're the president. If you pick second, you're the secretary. So the first 2, there is order associated with it, but the second 2, student 1, student 2, I don't care about. So For the second 2, I'm going to have to divide out by 2 factorial. Okay? So in other words, 20, 19, 18, 17 divided by 2. Because it's the last 2, I don't care about order. When you don't care about order, you divide by factorial by how many you have. I have 2 of them. They don't have order to them. Number 4. I want to make up an ID that consists of 4 letters. Repetition is not permitted. The first letter needs to be a B. So, what I need to do, pick 4 letters, right? Letter 1, letter 2, letter 3, and letter 4. But I noticed the first letter has to be a B, so we're going to label that one B. Where are they coming from? 26 letters. Start counting. In my first choice, how many ways can I pick a B? 1. There's only 1 letter B. Can I put it back? All the 4 letters have to be different. Repetition is not permitted. Since I can't put it back, there is only 25 letters now. The first letter, there was only 1 choice that I could make. It's a B. But the thing is, it's gone now. So when I go to the second letter, there's 25, 24, 23. I'm talking IDs. We have order. So the answer is 25, 24 times 23. Multiply that together. There's your answer. So notice how I dealt with the special condition of B. And then when I went to the second letter, I asked the question, do I still have 26 or do I have 25? I took 1 letter out of the batch. So it went down 1. Okay, so that's counting. Here are some probability problems. We got interruption here. Hold on. Okay, now we're on to probability. A bag contains 6 red, 7 blue, 10 yellow coins. 2 coins are selected and are replaced as they are selected. That's important here. You have to understand the experiment. Pick a coin, note the color, put it back, pick a second coin, note the color. What's the probability of picking a red first? Well, when I go to pick the first coin, my world consists of 6 red, 7 blue, 10 yellow. Definition of probability is how many ways can I do it? 6 ways. How many ways can I do anything? 23. 6 over 23. You take care of reducing fractions to lowest terms if that's what you have to do. Alright? Second one. Find the probability of picking a yellow second, knowing you picked a red first. When you're given information, you ask yourself, what does the world look like now? So I'm given, we picked the red first. What does my world look like? Well, all I know is after I pick the first coin, I put it back. So my world still has 6 red, 7 blue, and 10 yellow. Remember, I told you when you're given information, the conditional probability, you ask that question. Based upon the information given and based upon what you're doing, what does the world look like now? Here's my world. In this world, how many yellow are there? 10. In this world, how many things are there? 23. So 10 out of 23. Compare this to number 6. Number 6, a bag contains 6 red, 7 blue, and 10 yellows. But the only difference here is when I select a coin, I do not put it back. So, what's the probability of getting a blue first and a red second? The probability of blue first and a red second. I told you when you have an and, think of this formula. It works and you might not need it, but it does work. The probability of a blue first times the probability of a red second, knowing you have a blue first, okay? This formula works all the time. When you're doing 2 things at the same time, and you might want to consider that conditional probability formula. You need to have that memorized, okay? That's a given right there. All right, when I go to pick the first coin, and I want it to be blue, there are 7 blue coins. There are 23 to pick from. When you have a conditional probability, right here, given, when you have a conditional probability, Then you have to look at the world now. How is it different? I picked the blue first. I did not put it back. My world has 6 red, 6 blue, and 10 yellow to it. Remember, conditional probability, what happened to the world? That depends upon what you're given, and that depends on what you are doing. I'm given its blue one was picked first. I'm told I'm not putting things back. There's my world. How many of them are red? 6. How many are there? 22. You do the math. That will be your answer. Okay? You need to understand the concepts. I'm assuming you can do the multiplication and division. Next one. I want 2 blues. So if I'm going to get 2 blues, I need to pick a blue first. And I need to pick a blue second. Well, the formula says that's the probability of blue first, probability of a blue second, knowing I got a blue first. Blue first is 7 out of 23. A blue second, given blue first, I heard that word, given. Once I hear the word given, I ask what does the world look like? Well, I didn't put it back. I picked the blue. I didn't put it back, so 6 red, 6 blue, 10 yellow. Well, in this world, there are 6 blues. There are 22 things. So there's the answer. By coincidence, it's the same as A. Okay? See, if I told you I wanted a yellow first, let me just kind of mention it. If I wanted a yellow first and a blue second, then this would be yellow first and this would be yellow first, right? And now my world would look like 6 red, 7 blue, but 9 yellow. Remember, a conditional probability is all about information being given that may affect the way the world looks like based upon what you are doing. Number 7. Always feel free to stop the video. I'm moving right along here. My basket contains 3 apples, 4 pears, 7 bananas. Select a piece of fruit. The probability of not selecting a banana is, well, there are 7 ways of not picking a banana. 3 apples, 4 pears. There's 14 ways of doing something. 7 out of 14, 1/2. Probability of selecting a pear. There are 4 pears. There are 14 things I can do. 2 sevens. When you're talking about the word odds, the odds is the number of ways you can do it to the number of ways you can't do it. How many ways can I pick an apple? 3. How many ways can I not pick an apple? 11. Odds against selecting a pear. How many ways can I not pick a pear? 7 ways. How many ways can I pick a pear? 4. I'm sorry, 10. 10 ways. Remember, odds are how many ways you can do it to how many ways you can't do it. I can't pick a pear 10 ways. 2, how many ways you can't do it, so the opposite of can't pick a pear is pick a pear. 4. That was pretty good. Number 8, we have a table. I've discussed the table with you. Let's get to the problems. You stop the video, read all about the table. I'm picking a person. I want the probability that person likes soft music. How many people like soft music? 70. How many people are there? 130. Again, I'm leaving you to reduce the fractions to lowest terms. Okay? Well, there you go. Okay, I'll do one of them. That wasn't hard, right? I want the probability I pick a teenager and they like soft music. I didn't say they like soft music. I want they like both. Teenager, soft music, 30 people. How many people are in my world? 130. There's no given information here. But the next problem. An adult knowing they like loud music. Hey, when you're given information, what do you know? They like loud music. If they like loud music, here's your world. In this world, there are 10 adults. In this world, there are 60 people. So 1/6. Now, the last one, the probability of an adult or they like loud music, well, that's an OR. An OR has a formula to it. And here it is. The probability of this or that is the probability of A plus the probability of loud music minus the probability of both, right? But that's supposed to be allowed. That's the formula for an OR. Told you you need to have it memorized. Well, the probability they're in a doubt is 50 over 130. Pen's a little slow. So, loud music, 60 people like loud music. 130 people. We're not given any information here. So the word is the 130 people. They are doubts and they like loud music. 10. Do your math, and that's your answer. Okay? Remember, when you're given information, your world changes. People often confuse an and for given. These people are still in the 130. We didn't say they like music, soft music, or they were teenagers. Number 9. All right, we want the probability of A or B, right? I'm giving the numbers here. That's why you need to know the formula. The probability of A or B is the probability of A plus the probability of B minus the probability of both of them, right? You gotta know this formula and the other, the one for and. Okay? Now, I know what A is, I know what the probability of B is, and I know what the probability of both of them is. When you do your math here, it comes out to be 0.5. A problem like this, you don't even really have to understand probability. It's an algebraic problem. You solve for the unknown. You're given 3 out of the 4 things. You can solve for whichever one's missing. Not a bad problem, and typically something on the final exam. Back to the old word problem. Word problems mostly. Counting problem. Committee is to be selected from 2 instructors and 2 students from a list consisting of 5 instructors and 4 students. Now, how many committees are there possible? Well, I need to pick instructor 1, instructor 2, student 1, student 2. Instructors are coming from 5 instructors, students are coming from 4 students. Start picking, can't put it back. Start picking, can't put it back, right? So 5 times 4 times 4 times 3. Last question, is there order? They're just on committee. No difference. How many instructors? 2 times 1. How many students? 2 times 1. Remember, order and replacement are group specific. I picked 4 people, so it's not 4, 3, 2, 1. The teachers, there were 2. Students, there were 2. I consider them different groups. Final question. Expectation. The expectation of a game is the outcome multiplied by the probability of the outcome. Add them up, and then if there's a cost in the game, simply subtract it at the end. So we're playing a game, you're rolling a die, and if you get a 2, you win $8. So I win $8 with the probability of 1/6 because we're using a 6-sided die. The chances of getting a 2 is 1 out of 6, and I win 8. Oh, but if we get a 3, we win $4. So the chances of winning $4 is 1 out of 6. Now, there's 4 out of 6 ways of winning 0. That's really immaterial here, but I want to be thorough here. Here are the possible outcomes. Win 8, win 4, win nothing, right? 1/6, 1/6, 4/6. That's the expected value of the game. If you do your math, you end up with 8 over 6. 8 over 6 plus 4 over 6, right? Which is equal to 2. Now, that's the expectation of the game in a way without considering the cost. I just bring in the cost at the end because that's really, you have to pay the dollar. There's no probability associated with that, okay? It's just being picky here, I guess. But since I have to pay $1, my expected winnings is $1. Not a difficult problem on the final exam. Remember, how much can you win? What's the probability of winning that? How much can I win? What's the probability of winning that? How much can I win? Probability of winning that. Add that all up, you get a number. Then simply subtract off the cost of the game. And so that's $1. And that is it. Good luck, everybody.